couple of important things about it is we do go degrees Fahrenheit for obviously our Fahrenheit guy. We do go degrees Celsius for our Celsius. And for Kelvin, it is actually just capital K. For Kelvin, no degrees mark. So we don't use the degree mark there when we are using Kelvin. So we just say something like 273 Kelvin. As opposed to 98 degrees Fahrenheit or 98 degrees Celsius. Again, no degree mark. Now, in terms of sort of chemistry and science in general, really these are our two sort of guys that we come across the most. And usually in chemistry, we're going from Celsius to Kelvin, and that's sort of our very common sort of conversion. Probably outside of chapter 2, you won't probably come across too much Fahrenheit in chemistry. But again, you do need to be able to kind of convert between all three of these scales, but very rare a lot of times in chemistry problems that any temperature is sort of given in Fahrenheit. It can be, but I would say definitely Celsius all the time is given, like our thermometers in the lab, for example, and Kelvin is usually needed in a lot of formulas that we use. So a lot of formulas that we'll see this semester, and as you continue on in chemistry, you will see usually the temperature needs to be converted to Kelvin. So again, that's a very important temperature scale that we come across. Here's sort of the differences between Fahrenheit, Celsius, and Kelvin, and sort of the differences between its normal boiling point and its normal freezing point is really how we get to our conversions to go between it. So for example, as we go from Fahrenheit there, from freezing to boiling, it's like 180 degree difference. We have a 100 degree difference there in Celsius. And, you know, in terms of the differences is how we convert between the two. So let's talk about actually how to do that. So the one that you'll use the most is this one right here. If you want the temperature in Kelvin, you take the temperature in Celsius and you add 273. The real number is 273.15, which is how they got to 0.2. Pretty much 99.999999% of people will just use 273. So personally, I will just use 273. Most of the time, this 0.15, 0.2 gets lost when you sort of fix the answer at the end anyways. If you want to use the official number there, 273.15, you can. But again, most people will just use 273, and I think is perfectly fine. Also means another important sort of way is if you have the temperature in Celsius, if you want the temperature in Celsius, you take the temperature in Kelvin and you minus 273. I would say 9 times out of 10, you're doing this part of the conversion where you're taking it from Celsius to Kelvin, but going the other way is important as well. If you want degrees Fahrenheit, you take 1.8 times the temperature in Celsius plus a 32 to do that. And if you want to go to Celsius from Fahrenheit, you minus 32 and divide by 1.8. 1.8 is like that 9/5 if you learn that in fractions, right? If you take 9 divided by 5, you get 1.8. So that is, you know, sort of where that 1.8 comes from. Also, it's 180 if you remember units between freezing and boiling. So that's also where it sort of comes from. Now, we've been talking about significant figures and sort of the proper way of, you know, given answers in significant figures. With temperature, there's sort of a general rule that is made or used, and it really doesn't follow the kind of normal significant figures that we've been talking about in terms of how to give the answer. So the very simple rule, and the rule that you really should follow when you're doing nothing other than taking one temperature from one temperature scale to the next, and you're just simply doing that conversion, is when you do the conversion for temperature, your converted number should look just like the original number. And what that means is if the original number went to 1 decimal place, you should take your converted temperature to 1 decimal place. If the original temperature was a whole number, you should convert it into a whole number. So it's slightly different when we're talking strictly temperature conversions, going from one conversion to the next and just changing the temperature units. What we look at is not as strict in terms of significant figures, but whatever the original value was converted to make it look like the same sort of value. So the example that they have down here is they started with 10.1 degrees Celsius. When they did both of the conversions, you could see that the original number went to 1 decimal place. So the converted values also went to 1 decimal place. So that's really what you want to do when you're dealing with just temperature conversions. Whatever the original number looked like, make the converted temperature value look the same. That also means, again, if it went to 2 decimal places, your converted number should also go to 2 decimal places as well. And the reason for that really is this number here. For example, some people use 9/5, which is kind of like a fraction. Some people use 1.8. Some people use 1.80, as you see there. So there's a lot of sort of variations in terms of if you were trying to be super strict on the sig figs like we've been doing, you may end up with different ones depending on sort of the conversion factor that you use. So everybody just sort of comes together and goes, just make it look like the original number is what you should do with temperature conversions only. So again, out of all these past chapter 2, this is really the one that you'll use the most, where you want to convert it to Kelvin by adding 273. Outside of that, probably not going to use too many of the bottom 2. Also does mean, though, if you, for example, have a temperature in Fahrenheit and you want to get to Kelvin, you do need to take it from Fahrenheit to Celsius first, and then Celsius to Kelvin afterwards. All right. So why don't you try a few, make sure you get the right answers here. Convert the first one to Kelvin, next one to Fahrenheit, and lastly to Celsius. So take a couple minutes and see what you come up with. Again, make the answer look like the original number. Okay, so let's take a look. So on the first one here, we're going from degrees Celsius to Kelvin, which is a very common conversion that you need to do in terms of temperature. So remember that the temperature in Kelvin is the temperature in Celsius plus 273. So again, we're going to do 95.0 plus 273. Again, if you want to use the 273.2 or 273.15, you can. But most people, again, will just use the 273. That is going to give us 368 on your answer. Again, though, when we look at it, our original number here did go to 1 decimal place. So although on your calculator, you may just get 368 if you use 273, you would want, in our case, to put a 0 there and a Kelvin. And again, no degree sign or anything like that on the Kelvin, so it's just K. Again, if you did the 273.2, you would have 368.2 as your answer. And then obviously if you did the 273.15, you would round to the 368.2. So again, any of those answers would be okay, depending on which one you use. And like I said, in most people pretty much do just use the 273 on that. Any questions on that case? All right, so we want to go Celsius to Fahrenheit. And again, temperature in Fahrenheit is 1.8 times the temperature in Celsius plus a 32. 1.8 times 95 plus 32 here. Going to get us 203. Again, here on our calculator, we get 203. Our original numbers also going to 1 decimal place. So we would want to put that 0 in here. We would want to go degrees Fahrenheit on this guy here. So again, just in terms of temperature, we just maintain what it looked like originally when we're just doing that temperature conversion. And lastly, here we want to go from Fahrenheit to Celsius, and temperature in Celsius would be temperature in Fahrenheit minus 32 divided by 1.8, giving us 22.5 minus 32 divided by 1.8. So 22.5 minus 32 divided by 1.8. Gives us a negative 5.277, a whole bunch of sevens, right? Again, here we are looking at 1 decimal place. So we probably should take it to minus 5.3 degrees Celsius in this case. No, you don't have to put the T in front. I just do it because temperature. Sometimes you could do it like they wrote it, degrees Celsius equals degrees Fahrenheit minus 32. Other questions or questions on any of those? So again, temperature, slightly different, doesn't follow strictly the sig fig rules that we've been talking about. And again, it's just for temperature conversions where you want to do that. Any questions on any of those? I think you might have one more after this here. Yeah. So why don't you?
Sorry, I had a question.
Yep.
It was just I didn't get 5.3 from the final conversion when I subtracted them and then did the division.
So you took 22.5 minus 32, right?
Yeah, and then divided it by 1.8.
Then 1.8. So you got you should get minus 5.2777, a whole bunch of sevens. So again, you might want to, I don't know how you punch it in, but you might want to do 22.5 minus 32, hit equals, and then divide.
Okay, that's probably what it was.
Yeah, so sometimes, much like we were talking about with conversions, sometimes you try to punch everything in all at once. Depending on the way your calculator's programmed, it might give you the wrong answer. So usually if you're doing a bunch of multiplication or whatever, anything on top, you want to hit equals before you divide. And sometimes if you need to divide by multiple numbers, it's good to hit divide by the first number, hit equals, divide by the next number, hit equals, and usually you'll get the right answer. Sometimes, again, if you kind of try to punch them all in at once, you'll end up
All right,
getting it.
got it. Thank you.
Other questions? Okay. All right, so give this one a go, see what you come up with. Hopefully the right answer is up there. Okay, so in this one, we're starting with Fahrenheit. We're going to Kelvin. So again, really the only sort of route to do that is you need to take it from Fahrenheit to Celsius first, and then go from Celsius to Kelvin. So again, we're going to go Fahrenheit to Celsius. So temperature in Celsius, again, would be our Fahrenheit minus 32 divided by 1.8. That's going to give us our Celsius, and then we could go to our Kelvin by adding our 273 to it. So again, kind of a two-step process to do that. So we'll start with our Celsius here. So we'll take our 102 minus 32 divided by 1.8. Going to give us, it's going to give us 38.888, a whole bunch of eights all the way down. Again, at this point, I'm not going to round too much here because I know I'm going to take this number and then kind of bring it up here anyways. So basically, I'm going to take that number and add we'll go around a 9 here, 273 to it. And that's going to give me 311.88. Again, a whole bunch of eights going on there. This will now be Kelvin. In terms of where I should end up with my answer, as you can see from these answers, if we look at our original number, it is a whole number, which means we should obviously end up here. Looking at this number, it's above 5, so we are going to round. So it looks like 312 Kelvin should be where we end up in terms of that answer. Any questions on that? And again, like I said, probably outside of chapter 2, you won't see too much of Fahrenheit